guys, so today we're going to be talking about exponential growth and decay, but we're going to be specifically talking about some real-world examples with this exponential growth and decay. Okay? So guys, just like we learned over the last class, we have this exponential function, okay? And it's this form: f of x is equal to a times b to the x power. And guys, it is growth when that b value is bigger than 1. Okay? And so today, we're going to be talking specifically about not just this b, but we're going to be talking about a rate of growth. Okay? You will use this. This is very, very common in real-world situations. All right? And so this can be written, and it can be broken down a little bit. And this guy right here, okay, where y is equal to a times 1 plus r to the t power. So guys, in this case, r is going to represent our rate of growth. All right? So kind of go with me on here. Because guys, check it out. Your a value is the same. In our original function, your a value represented that y-intercept. In the real-world examples, it's going to represent that initial or starting amount. But guys, I want you guys to understand it's really the same thing as your y-intercept. Okay? Your y value, the y equals, this is going to represent your final amount. Okay? This r, the 1 plus r, the r represents your rate of growth. And guys, oftentimes, that rate of growth will be given to you as a percentage. So you will need to change the percentage to a decimal. All right, guys? Sorry, I know that's really tiny. So your rate of growth, it will be given to you as a percentage, but you need to change it to a decimal. And then your t is just equal to your time. And what I want you guys to notice here is this whole thing, the 1 plus the r, is the same thing as your b value, okay? That 1 plus r is the same thing as your b value. So when we are doing word problems, we want to identify all the correct variables. And then we're going to substitute them in and simplify it. And then we find our value of t, and we solve for the final y, okay? So this looks like a lot of steps, but it's actually not too bad. So let's read through this problem. It says the population of a city is increasing. Guys, if it's increasing, is that going to be growth or decay? Growth. So if you see words like increasing or interest rate, because guys, if you put money in at the bank and there's interest, it's growing, okay? So you're increasing at a rate of 4% each year. So they give us the rate right off the bat, okay? So I'm going to go ahead and then let's keep reading. In 2000, interesting, there were 236,000 people in the city. And we want to write an exponential growth function to model it. And then we want to go on and we want to find the population in 2009. So we're going to do a few things here. So guys, what is my starting amount? What is the starting, what do we start with? How many people were in the city at the beginning of the problem? 236,000, right? So our A value is 236,000. Are y'all comfortable with that? That's how much we had at the beginning. My rate is equal to that 4%. But remember, I said we don't want to keep it as a percent. We want to change it to a decimal. So guys, whenever you change a percent to a decimal, you move that decimal point 2 times. So my rate is actually equal to 0.04. Y'all comfortable with that? 4%, move the decimal 2 places, and we get 0.04. Okay? So if we know the A, God bless you, we know the A, and we know the rate, then we can write our equation. We can plug it in to this exponential growth equation. So I'm going to go here. I'm going to say, okay, my y is equal to my a value, my starting amount, 136,000, times 1 plus, because it's growth, 0.04, raised up to the t power, the time, years. Now, guys, you can also put x as long as you know that x is time, all right? But in most real-world situations, that x value is always going to be a time, so they just change it to t, all right? Now, this right here is not quite simplified. We want to actually go in and simplify this real quick. We want to say y is equal to 236,000 times, well, guys, what's 1 plus 1.04? Oh, wait, sorry, I'm giving you all the answer. 1 plus 0.04. It is 1.04. So inside this right here, we are going to put 1.04. And then we are going to raise that up to the t power. So this right here is my simplified exponential function. Do y'all feel good about that? Is that too bad? It's just plugging in your values and simplifying them, okay? And what you'll notice is the 0.04 is your rate of growth. The 1.04 represents that growth factor, that b value, okay? And is my b value bigger than 1? Yeah, so it's growth, okay? Because we're adding to 1, so it's considered growth. So now if we want to actually find the population in 2009, well, guys, if we started in 2000 and we want to know what it is in 2009, well, guys, we have to do 2009 minus 2000, right? So what is my t actually going to be equal to? 9. Do y'all feel good about that? So my t is equal to 9. So now we're going to plug this all in. We're going to say, okay, y equals 236,000 times 1.04 raised up to the 9th power. So instead of t, we now plug in our 9. Y'all feel good? Now, guys, you will absolutely 100% need a calculator for these today. Okay? So 236,000 times 1.04 raised up to the 9th power. You do your little caret right there, and you get up to the 9th power. You hit enter, and this is what we get. We get y is equal to 335,901.58. But guys, or I guess 59 really, if you round it. Okay, but guys, we're dealing with people. So would we ever do a decimal of a person? No, we don't talk about half of people. We don't talk about parts of people. So we want to, when we're talking about people, we want to round it to whole numbers. Does that make sense, y'all? So we want to go ahead and we are going to say that this is 335,902 people. So in 9 years, the new population would be approximately 335,902 people, according to this exponential growth model. Do y'all feel good about that? Okay, so this is not too different. The biggest thing is this rate, all right? Finding that rate. So this is exponential growth. It's when we add the rate. Well, guys, in exponential decay, and we can go ahead and highlight this one too, okay? In exponential decay, what do you think we're going to do with that rate? Instead of adding it, what are we going to do? Subtract it, because we're taking it away from 1. All right, guys? So for exponential decay, it's the same basic function, right? Where we have an a and we have an a, that's the initial amount, or the y-intercept, okay? And we have that y, or the f of x. Those are going to be the same. That's your final amount. But this time, guys, because we're subtracting our r, this r represents a rate of decay. And guys, Remember, your B value in exponential decay is between that 0 and 1. It's less than 1. And so we can write it with 1 minus the R. And just like that, make sure you change it to a decimal. All right, guys? It can't be a percentage. They'll probably give it to you as a percentage, but you have to change it to a decimal. And just like with exponential growth, your t is still going to be that time. Okay, guys? So we have these functions. And we will see that this 1 minus r is our b value. Okay? So let's take a look here. So this one is going to be very similar. The first one, our population was increasing. I guess people were having babies or people were moving there. There was something going on. Okay, now we're going to look at this one, and our population of this city is decreasing. So maybe business is bad, or it's like a small little town or something. But for some reason, the population is decreasing. All right? And so we're going to see what we can do here. So because our population is decreasing, that is going to mean decay. And it's decreasing at this rate of 6% per year. But in 2000, there were only 35,000 people. Oh, man, it's like a small town already. Okay? And then it's going to get even smaller. And we want to write an exponential decay function. Okay? They also kind of give it to you that it's decay to model the situation. And then we want to find that population in 2012. All right, guys? So what is my initial value? How many people do we start with in this little city? Only 35,000, right? Okay. And what is my rate of decay? 6%. But how do I write that as a decimal? I take my decimal and I move it. So that's really 0.06. Are y'all comfortable with that? That 0.06 is what we want. Okay, so now that we know these two things, we can go ahead and write our equation. So we're going to say y is equal to my a value, my initial starting value, that y-intercept, times 1 minus the r, which is 0.06, right? And then we're going to raise that up to the t power. So guys, now we have this 1 minus the 0.06, minus your rate. So we're going to write our equation as y equals 35,000 times, but now, if you can't do it in your head, that's totally fine. I'm going to do 1 minus 0.06, and we get 0.94. So guys, now that b value, that rate, because our rate of decay is 6%, that decay factor is 0.94. Is that number smaller than 1? Yeah, so it's decay. All right? And it's raised up to the t power. Okay? So this right here represents our exponential function. So guys, on your homework, you will have to do things where you actually type out this equation right here. Okay? With the x value and all that stuff. And then you also have to give the answer. All right? And so when we have these, we see this, and now what is my t value going to be? 12, because it's 2012. It's nice when it's a nice, easy number like 2000, isn't it? So my t is equal to 12, okay? So then we're going to go ahead and we're going to replug this in, but with a t of 12. So that's going to be 35,000 times 0.94 raised up to the 12th power. Now guys, yet again, this is not something you can do to in your head. You don't want to multiply 0.94 to the 12th power in your head. So you'll take your calculator, 35,000 times 0.94, and then you raise it up. You do that little caret top button to the 12th power. And when we do this, we get this lovely number, which is 16,657.21. But do we want to do decimal points of people, y'all? No, we don't. So this is going to be 16,657 people. All right? How do y'all feel about these? Are they too bad or are they okay? Okay, awesome. So guys, honestly, exponential growth and exponential decay are not too bad. It's like identifying the variables and plugging them in. That's what exponential growth and decay is. And then it's just using your common sense of like, oh, if it's decreasing, it's decay. If it's increasing, it's going to be growth. So let's take a look at this number 1 and number 2 here, okay? So now we're dealing, a lot of times you deal with people or money, or they also like bacteria, weird things like that, okay? So let's do a couple that have to do with money. Okay, annual sales. So what does the word annual mean? Do y'all know? Yeah, yearly. So guys, this is happening every year. So our yearly sales at a company are $372,000. All right? That is not my salary, but that's okay. So that is the annual sales at a company, $372,000. And it's increasing. So guys, is that going to be growth or decay? Growth. So we're going up, so this has got to be growth, at a rate of 5% per year. So let's identify our A. Which one is my A, y'all? The 372,000. Okay? What is my R going to be? I guess I can write it out here. Yeah, A is equal to 372,000. Yikes. I'm struggling. Okay, the R is 5%. So if we're going to write that as a decimal, it's going to be 0.05. Are you guys comfortable with that? I'm not jumping too far here. So this becomes Y is equal to 372,000 times 1 plus, because it's increasing, 0.05. And we raise that up to the t power. Okay, we're going to raise that up to the time, or to the x power. Okay, so if we want to write this in the fully simplified form, we would say y is equal to 372,000 times 1 plus 0.05. We do 1 plus 0.05. Those are a little bit easier to do in your head. That's 1.05. Okay? If you can do it in your head, I do encourage you to do that. Raised up to the t power. Alright? So that would be our equation. And then it says, what will the value be in 8 years? So what is my t equal to, y'all? 8. We don't even have to do any subtraction, do we? That's wonderfully. That's wonderful, wonderful. Wonderfully. Come on. There's a reason I teach math. Okay? So then we go, okay, 372,000 times 1.05 raised up to the 8th power. Now this is probably going to take you a little bit less time because you're not changing out your colors like I am. But 372,000 times 1.05, and you raise that up to the 8th power, and we get this lovely number. Okay? Now guys, we get 549,613.425. But guys, when we're talking about money, I want every single penny, so you want to round it to the nearest hundred. So 4.42 becomes 0.43 because that 5 rounds it up. So this is going to be, in 8 years, my value is 549,613.43. I'm going to put my little dollar sign. We got these dollars right here, okay? Y'all feel good about that? Now, if you guys want to do your little comma there, you can do your comma. I just copy it right out of the calculator. Y'all feel good about this growth right here, yeah? Okay, so now let's look at number 2 here. Number 2, monthly car sales for a certain type of car are $350,000. So that looks like, ooh, we're dealing with monthly now, okay? And it's decreasing, so what does that mean? Decay, at a rate of 3% per month. So my A value is 350,000. My R value is what? 0.03. And it's decreasing. So we're going to plug this into the exponential decay function, right? It almost looks virtually identical, but the difference between exponential growth and exponential decay is for exponential growth, we do 1 plus. For exponential decay, we do 1 minus. 1 minus 0.03 times, or raised up to the t power. So if we simplified this, it would be y equals 350,000 times 1 minus 0.03 should be 0.97, which is smaller than 1, which is decay, raised up to the t power. So this right here represents my exponential function. And then, I'm not going to bring my calculator anywhere because we're going to use it in just a second. What will the value be in 6 months? So that's my t. So I get to plug this in. Y equals 350,000 times 0.97 raised up to the 6th power. So I'm going to do 350,000, yep, 4 zeros there, times 0.97 raised up to the 6th power. And when we do that, wow, that's a big number. Oh, it's decreasing. Okay, so I guess these cars aren't so popular. So that's 291,540.20. So the new monthly sales, oh man, they're only selling $291,000, $540.20 of that car every month. That's crazy. What kind of cars are these? Okay, so you guys feel good about this? Is this too bad, guys, to go and just plug it in and play? All right, so what I want you guys to do is I want you guys to use these examples. I want you guys to flip to page 9. And guys, I want you guys to do number 3 and 4 on your own. Okay, guys? I want y'all to do numbers 3 and 4 on your own. So right now, I want you guys to go ahead and work. Identify your A. Identify your rate. Plug it in. Okay? But you have to recognize, is it exponential growth? Is it exponential decay? We need to see. Okay, guys? So I want y'all to do that right now. And then we're going to see what we have. Okay, good question. Okay, so hold on. All right, guys, so you guys were working on numbers 3 and 4. So let's talk about these guys together here up on the board. Okay, guys? So for numbers 3, we recognize that this was decay because it was decreasing. So, guys, I actually just wrote the word decay so I wouldn't screw it up and I wouldn't forget, right? So that is one way that you can do that. You can be like, oh, it's decay, so it's decreasing. All right? And then on here, too, guys, what I did was I looked at that and I saw that it was decay. We identified our A value. We identified our rate, which is 2%. Now, guys, some of you guys, if you're struggling with how to turn your rate into a decimal, then, guys, one thing that you can do to turn your rate into a decimal, you can always move that value to decimal places. But also, guys, what you can do is you can take your percentage and divide it by 100. And that is going to equal that 0.02. So if you struggle with percentages, just take your percentage and divide it by 100. Okay? Take your percentage and divide it by 100. So that would give you 2 divided by 100 would give you that 0.02. Okay? So once we had our starting value and our rate, we could plug these guys in and we got 0.98 as that decay factor. So 1200 times 0.98 to the t. We wanted to know what it would be after 5 years, so we plugged our 5 in. And we got 1084.70, but remember we're talking people, so let's round to whole numbers. So 1,085 people. Number 4 is very similar. We recognized our A. We saw that it was increasing, so that meant growth. And the rate is 3%. Guys, so that's 0.03. If you struggle with that percentages, you can just do 3 divided by 100. And that will give you that 0.03. Okay? And so then we go here, we look at this, and we say, okay, we plugged in all our values, and we got y equals 4,200 times 1.03, because it was 1 plus 0.03, to the t power. Okay? But we want to know specifically what it's going to be in 7 years, so we plugged in our 7, and we got 5,165.47, but once again, We don't like to do decimal points of people, so it's 5,165 people. All right, you guys feel good about those? Okay, so our last thing, you are going to have some problems in your homework where you're just, this is all you're doing, and it's going to want you to give your answer, okay? And then, guys, you're also going to have some problems where you just have to identify the growth or the decay percentage. Okay, guys? So I'm going to kind of walk you guys through these. For some reason, they're not numbered. I don't know why. Okay? So we want to identify if it's growth or if it's decay, and then what that rate of growth is. Okay? So let's look here. First of all, when you're looking at this function right here, 0.98, is that, I'm going to zoom in a smidge, is that growth or is that decay? It's decay. Why is it decay? It is less than 1. Okay? So because it's less than 1, this represents decay. And decay is decreasing. Do y'all feel good about that? Decay is decreasing. Okay? But we want to know how much is it decreasing by. We know that our decay factor is 0.98. But what's the percentage of decreasing value there? Okay? The percentage of decreasing value, what you do is you do this factor, 0.98 minus 1. Okay? We are going to subtract 1. And what's going to happen when we do this is we get 0.98 minus 1. Well, guys, do that in your calculator. What do you get? It's a negative 0.02. So, guys, if it's a negative number, does that make sense because your rate is decreasing? Yes. But, guys, we want to know what is the percentage of decreasing. So now we're going to go the opposite way. So if our rate is 0.02, well then, guys, the percentage is going to be, I'm going to do this right here. I'm going to move it twice. My percentage is 2%. So I am increasing by 2, or decreasing by 2%. It is 2% less. Okay? So I am decreasing by 2%. Because, guys, it is, basically you have to think, how far away from 1 is it? Well, it's 0.02 away from 1. And it's decreasing. So it's a 2% decrease. Okay? So you always do this little number minus your 1. All right. So now let's take a look at this next one here. I guess I should have just done all pink. I don't know why I switched, okay? Just work with me. I'm sorry, guys. Okay, so it's 2%. All right? Then we're going to go here. What is this guy right here? 1.75. Is that growth or decay? It is growth because it's bigger than 1. If it's growing, then it's increasing. Okay? But we want to know by how much percent is it increasing. Well, what you do again is you take your number, 1.75, and you subtract your 1. And when we do that, we get 0.75. Okay, now that 0.75 is my rate of growth. So if I move my decimal point 2 points, that becomes 75%. So it is a growth rate of 75%. Does that make sense? We're just basically undoing. Up here, we were subtracting it from 1 or adding it to 1. Now we want to find, okay, what would we have to do? This one, we would have had to add 0.75. That one, we would have had to subtract 0.02. So that's a 2% growth. This is 2% decay. This is a 75% growth. Okay? Now we're going to take a look at this down here. Okay, is this going to be growth or decay? Okay, why is it decay? It's less than 1. That 0.75 is less than 1. So this represents a decay, which represents a decrease. So in order to find how much it's actually decaying, you do 0.75 minus your 1. Well, guys, this is going to give us a negative number. 0.75 minus 1 gives us negative 0.25. So we're going to go ahead and move our decimal points 2 places, and we get 25%. Okay? So that 25% is a 25% decrease. Okay? It's like we're subtracting that 0.25 from the 1. So it's a 25% decrease. Do y'all feel good about that? Let's do another one. Okay? These you just have to practice. Okay? So I want you guys to do these two on your own, these fourth and this fifth one. First, just recognize, is it growth or is it decay? If it's smaller than 1, it's decay. If it's bigger than 1, it's growth. So I want you guys to recognize the very first thing you can do is recognize if it's growth or if it's decay. And then what we can do is we can actually find our value. So you always take your 0.57 minus 1. Ooh, this is going to be a negative value because it's decay. So that is a 43% decrease. All right? We have a 43% decrease. And last but certainly not least, we take our value here, 1.03. We subtract our 1. And when we do that, we get 1 point. This is a little bit easier, I feel like, to do. You don't necessarily have to do it on the calculator. You get 0.03. It is positive because it's growth. We move that sucker twice, that little decimal point, and we get a 3% growth. All right, guys? So for these, the biggest thing that you can do is you can recognize, is the B value bigger than 1 or smaller than 1? If it's smaller than 1, it's decay. If it's bigger than 1, it's growth. All right? And then what you want to do is basically figure out how far away from 1 is it. Okay? In this case, we were 75% above, right? 0.75. We were 25% below because it was negative 0.25. In this case, we were 43% below the 1. And in this case, we were 3% above because it was increasing. All right?